everyone. How are you? I hope you are all doing great today. By the way, we are now on our quarter 2, week 1 to 2 in Mathematics 9. And we're going to discuss about different types of variations. Okay, so let's discuss first about direct variation. So let's define. There is a direct variation whenever a situation produces pairs of numbers in which their ratio is constant. So we have the following statements so that a situation will be a direct variation. So y varies directly as x. So that is the first statement. Next, we have y is directly proportional to x. And the third one, we have y is proportional to x. You will determine a given situation or problem if it is direct variation by simply look at those keywords. We have directly, proportional, and proportional. So may be translated mathematically as y is equal to kx, where k is the constant of variation. For two quantities, x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. Okay, so we have here the graph of direct variation. So the graph of direct variation is a straight line that passes through the origin whose slope k is the constant of variation. So let's look at the graph of y is equal to 2x. So we have here the graph. So as you can see, we have here a straight line that passes through the origin. So we have here the origin and we have here the straight line. Okay, so the graph of y is equal to 2x is a straight line passing through the origin with a slope of 2. Again, so our slope or k here is the 2. Okay, so we have direct variation example number 1. So we have the problem. If 3 men earn 180 pesos in one day, how much will 15 men earn at the same rate of pay? Okay, so the first step, we have to write an equation. So what will be the x here and what will be the y and the constant? Okay, so we have the equation 180 is equal to k times 3. So our 180 is the y, our 3 men is the x, and we're going to find the k or the constant. Okay, find the constant of variation. So in order to get or to find the constant, we're going to divide both sides by 3. So we have now 180 divided by 3 is equal to k or the constant. So 180 divided by 3 is very good. 60. So our constant now or k is equal to 60. Next, use the constant of variation along with the given information. So we have y is equal to kx as our equation in direct variation. We have now our constant, which is 60, and we have again our x, which is 15 men. So we're going to get the product of 60 and 15. So the answer is y is equal to 900. So what will be our conclusion here? Okay, therefore, 15 men will earn 900 in one day at the same rate of pay. So that is easy, right? Yeah. Next, direct variation example number 2. If a boat travels 132 miles in 11 hours, how far can it travel in 38.5 hours traveling at the same rate of speed? Okay, first, write an equation. 132 is equal to k multiplied to 11. So our y is 132 miles and our x is 11 hours. So again, we're going to find the constant of variation. So in order to get the constant variation, we're going to divide both sides by 11. So it will become now 132 divided by 11 is equal to k, or the constant of variation. So 132 divided by 11, that is 12. So our constant of variation is equal to 12. Next, use the constant of variation along with the given information. So again, our equation for direct variation is y is equal to kx. Now, we're going to substitute 38.5 hours and the constant. So we have y is equal to 12 multiplied to 38.5, and that is y is equal to 462. And we have our conclusion. The boat can travel 462 miles traveling at the same rate of speed. Again, that was easy, right? Yes, that was easy. Next type, we have the inverse variation. So an inverse variation occurs whenever situations produce pairs of numbers whose product is constant. For two quantities x and y, an increase in x causes a decrease in y, or vice versa. We can say that y varies inversely as x, or the equation y is equal to k over x. The statement y varies inversely as x translates to y is equal to k all over x, where k is the constant of variation. So we have the graph of inverse variation. The graph of inverse variation is a rectangular hyperbola such that the product of x and y is k, the constant of variation. So the difference between direct and inverse variation in the graph is that in direct variation, we have the straight line that passes that line on the origin. And on the other hand, in inverse variation, we have a rectangular hyperbola in the graph. So as you can see, we have here, it's like a letter L and inverted letter L. So let's look at the graph of xy is equal to 2. The graph of xy is equal to 2 is a rectangular hyperbola whose product of x and y is always 2. So that is the graph of inverse variation. Okay, so we have inverse variation example number 1. Okay, so the speed of a gear varies inversely as the number of teeth. If a gear which has 36 teeth makes 30 revolutions per minute, how many revolutions per minute will a gear which has 24 teeth make? Whew. Okay, so we have our first step, write an equation. So here, we now have a equation which is y is equal to k over x. Or, we have now k is equal to y multiplied to x. So we have here our y, which is 30, and our x is 36. So if we multiplied those quantities, we will now get the constant of variation, which is k is equal to 1080. So use the constant of variation along with the given information. So we have again our formula or the equation for inverse variation, which is k is equal to y multiplied to x, or we have y is equal to k over x. So here we're going to substitute the value of y, which is no value, and we have the value of x, which is 24 teeth, and we have the constant. So in order to get the value of y here, we're going to divide both sides by 24, so that we have y is equal to 1080 divided by 24. And that is y is equal to 45. So therefore, a gear with 24 teeth will make 45 revolutions per minute. So that was easy, right? Yes. Okay, next we have inverse variation example number 2. If 8 snow plows can plow the airport in 6 hours, how many hours will it take 3 snow plows to plow the same airport? First, write an equation. So we have 6 multiplied to 8 is equal to k. We're going to find the constant. So 6 is the value of y and 8 is the value of x. So in order to find the constant of variation, we're going to multiply those two quantity, which is the x and the y. We have k is equal to 6 times 8 is 48. Now use the constant of variation along with the given information. And now we're going to find the value of y. So in our second statement, or the problem, how many hours will it take 3 snowplows to plow the same airport? So we have the value of y, which is no value of y. We're going to find it. And the value of x is 3. And our constant, which is 48. So divide both sides by 3. We have now the outcome. Y is equal to 48 divided by 3. So what is the value of y? Very good. Y is equal to 16. Therefore, it will take 3 snowplows 16 hours to plow the airport. Again, that was easy, right? Yes, that was easy. Next type is the joint variation. Joint variation is the same as direct variation with 2 or more variables. The statement A varies jointly as B and C means A is equal to K times B times C, or K is equal to A divided by B times C, where K is the constant of variation. Joint variation example, letter A. Suppose y varies jointly as x and z. Find y when x is equal to 9 and z is equal to 2, if y is equal to 20, when z is equal to 3, and x is equal to 5. Okay, so that is very hard to solve, but we have two methods to solve that problem. So we have first identify the y sub 1 and the y sub 2. Under y sub 1, we have y sub 1 is equal to k multiplied to x sub 1 times z sub 1. And on the other hand, y sub 2 is equal to k times x sub 2 times z sub 2. So in y sub 1, we have 20. In x sub 1, we have 5. And in z sub 1, we have 3. So we get those substitutions from the second statement. And we have now in our y sub 2, which is the one we're going to find. And we have the x sub 2, which is 9. And z sub 2 is equal to 2. We have the method number 1. Okay, so we have here 20 is equal to k times 5 times 3. So we have here the y sub 1, which is 20, the k, which is the constant, 5, which is the x sub 1, and 3, which is the z sub 1. Okay, so let's simplify first this side. K times 5 times 3. And that is 15 or 15k. Divide both sides by 15. This will be now the outcome. 20 divided by 15, which is the k. And if we're going to have the lowest term of 20 divided by 15, that is 4 over 3. So how did we get this 4 over 3? So just simply divide both the numerator and the denominator by 5. 20 divided by 5 is 4, and 15 divided by 5 is 3. Since we have now the constant, let's substitute now the constant to the first statement. So we have a second statement rather. Y sub 2 is equal to the constant, which is 4 over 3. Next, we have the x sub 2, which is 9, and the z sub 2 is 2. So let's simplify this. 4 over 3 times 9 times 2, and our y sub 2 is 24. That is our method number 1. Next, in method number 2. So in method number 2, let's get this. Since we're going to find first the constant, so in finding the constant, we have y sub 1 over x sub 1 z sub 1. And on the other hand, the y sub 2 is equal to k times x sub 2 times z sub 2. If we're going to find the k or the constant, it will be k is equal to y sub 2 over x sub 2 times z sub 2. Okay, so since we're going to find both constant in y sub 1 and in y sub 2, let's now eliminate the constant. So that it will be y sub 1 over x sub 1 times z sub 1 will be equal to y sub 2 over x sub 2 times z sub 2. This will be now our equation. Now we are ready to substitute the values of our equations. We have y sub 1, which is 20. Next, x sub 1, we have 5. And z sub 1, we have 3. Next, at the right side, we have y sub 2. We don't have y sub 2, so let's just simply write y sub 2. Next, we have x sub 2. We have 9. And z sub 2, we have 2. Let's simplify this. We have 15 y sub 2 is equal to 360. Divide both sides by 15. Y sub 2 is 24. So are they the same? Yes. So any of the two, if you choose method 1 or method 2, they are still the same. Joint variation example, letter B here. Suppose y varies jointly as x and z. Find y when x is equal to 9 and z is equal to negative 3 if y is equal to negative 50, when z is equal to 5 and x is equal to negative 10. Okay, so again, let's get the y sub 1 and the y sub 2. So in y sub 1 is equal to k times x sub 1 times z sub 1, and in y sub 2 is equal to k times x sub 2 times z sub 2. So these are the values of y sub 1, which is negative 50, x sub 1 is negative 10, z sub 1 is equal to 5, y sub 2 is equal to y sub 2, because later on we're going to find this. Next, x sub 2 is equal to 9, and z sub 2 is equal to negative 3. So let's start first in method 1. Let's get the y sub 1 is equal to k times x sub 1 times z sub 1. So y sub 1 is negative 50, x sub 1 is negative 10, and 5 is the z sub 1. We're going to find the constant. So negative 10 times 5, that is negative 50. So we have now, divide both sides by negative 50. This will be now the outcome. Negative 50 divided by negative 50. Our constant is k is equal to positive 1, because negative divided by negative is positive. Next, let's just move on to this part, the y sub 2. Now in y sub 2, we have k times x sub 2 times z sub 2. Our k is 1, our x sub 2 is 9, and our z sub 2 is negative 3. So 1 times 9 is positive 9, times negative 3, that is negative 27. Next, in method number 2. Okay, so just like our discussion in our first example in joint variation, we're going to get the constant or the equation for constant and then eliminate the constant. We're going to make equal these two equations. So we have now this equation, and we're going to substitute the values of this one. So let us substitute the values of these equations from the givens. We have y sub 1, which is negative 50, x sub 1, we have negative 10, z sub 1 is positive 5, y sub 2, that is the missing, and x sub 2, we have 9, and z sub 2 is negative 3. So simplify those equations. We have now negative 50 y sub 2 is equal to 1,350. So divide both sides by negative 50. The outcome will be negative 27. So are they the same? Yes, they are the same. So any of the two methods you will use, you will get the same answer. Next, we have here a combined variation. As you can see, I didn't include combined variation in our types of variation because in combined variation, from the word combine, you may use both direct and inverse variation in one problem that is combined. So let's take a look. We have combined variation number 1, or example number 1. When one quantity varies directly and inversely as two or more quantities. So as you can see, it combined the direct and inverse variation here. So suppose if varies directly as G and F varies inversely as H, find G when F is equal to 18 and H is equal to negative 3. Another statement, if G is equal to 24 when H is equal to 2 and F is equal to 6. Okay, remember that in the direct variation, we have our equation y is equal to kx, and in indirect variation, we have the equation xy is equal to k. Or, we have y is equal to k over x. Okay, so the first statement, if f varies directly as g, so g goes in the numerator. So it will become f varies inversely as h, so h goes in the denominator. So this will be now our equation. F sub 1 is equal to k times g sub 1 over h sub 1. And f sub 2 is equal to k times g sub 2 divided by h sub 2. So we have here the constant. So if we're going to find the constant here, we have now the new equation, k is equal to f sub 1 times h sub 1 divided by g sub 1. And for this one, we have now k is equal to f sub 2 times h sub 2 over g sub 2. So since we are going to find both the constant, just eliminate this k and we'll now get this f sub 1 times h sub 1 divided by g sub 1. So we're going now substitute the following equations by the givens, by using the givens. So we have the f sub 1, which is 6, h sub 1, which is 2, g sub 1 is 24. So we have here in the last statement. And the other one, we have f sub 2, which is 18. And then h sub 2 is negative 3. And we're going to find the g sub 2. So as you can see here, find g. So simplifying this equations, we have now 12g2 or 12g sub 2 is equal to negative 1,296. and divide both sides by 12, we will now get g sub 2 is equal to negative 108. So that is very easy. So if you notice, just like in joint variation, we use the method number 2 in the combined variation. Let us now move on to combined variation example number 2. Again, when one quantity varies directly and inversely as two or more quantities. Suppose A varies directly as B and A varies inversely as C. Find B when A is equal to 7 and C is equal to negative 8. If B is equal to 15 when C is equal to 2 and A is equal to 4. Okay, so again, we have the equation for direct variation, which is y is equal to kx, and the equation for inverse variation, we have xy is equal to k, or we have y is equal to k over x. So let's start this. Okay, A varies directly as B, so B goes in the numerator. Next statement, A varies inversely as C, so C goes in the denominator. Now we have the equation, A sub 1 is equal to K times B sub 1 divided by C sub 1. And on the other hand, we have A sub 2 is equal to K times B sub 2 divided by C sub 2. And now we're going to solve the value of K. So in this equation, we have now K is equal to A sub 1 times C sub 1 divided by B sub 1. And on the other hand, we have K is equal to A sub 2 times C sub 2 divided by B sub 2. So since we're going to find both equation, the constant, we're now going to get their equation A sub 1 C sub 1 divided by B sub 1 equate to A sub 2 times C sub 2 divided by B sub 2. Okay, so we have now here the substitution from the equation using those givens on the problem. So we have the A sub 1, which is 4, C sub 1 is 2, and the B sub 1 is 15. And on the right side, we have the A sub 2, which is 7, and C sub 2 is negative 8. And we're going to find the B, or the B sub 2. So simplifying this equation, we will now get the 8B sub 2 is equal to negative 840, or negative 840. Divide both sides by 8. Our B sub 2 now is negative 105. That was easy, right? Yes, that was easy. So those are the different types of variations. I hope that you learned all the types of variations. Let's have a recall. So the first type is the direct variation. Second is the inverse variation. The third is the joint variation. And the fourth, or the additional, is the combined variation. So this variation stuff is pretty easy. Just like this kid She said, I feel like jumping for joy. Ooh. And this lady, oh my, I think I'll just push the easy button. So this is the easy button. That was easy.